All right, so let's formalize with a proof. We'll do a flowchart proof. In the book, it does a 2-column proof, so you can look at the textbook pages to see this same proof as a 2-column style. But I'm going to model a flowchart proof in this lesson. So we're trying to prove, we've already talked about our plan for the proof, so now we just need to put all our boxes in the right places and point with arrows from one box to the next. And just to recap, your proofs are structure with the statement on top of your reason and then boxed in. And just put a line separating your statements from your reasons. And so the easiest points that we can earn in our understanding of proofs is always going to be your given. So put that in your proof space immediately. So we know that triangle, we're given triangle ABC. And the reason is given. So before we can create this picture, we just start with a triangle ABC. As previously noted, we created and sketched in this line. So that will be something that we have to include in our proofs. It's not something that we're seeing as a given, but it is something that we can create in our picture. So this is just an implied understanding from the picture. And those can always be in your proofs, and they're treated similarly to the way you treat givens. And we'll put them in the top row with the given, in the top row of your proof. So we see that we draw line BD parallel to segment AC. And the reason is a line and a non-collinear point implies parallel line. So we had our line, our original line was AC, that was a part of our given shape. And B can be treated as a point not on line AC. And through that point B, we can have a line that's parallel to AC. And the next thing that we can conclude is that because of this line, that auxiliary line that we sketched through B, we have 3 different angles. And because they're adjacent to one another, you can say that the measure of angle A plus the measure of angle 2 plus the measure of angle 5 is 180 degrees. And the reason we can say that is because adjacent angles implies angle addition postulate, which it's fine to shorten it down to AAP. So angle addition postulate is what allows us to say that measure of angle 4 plus measure of angle 2 plus measure of angle 5 is equal to 180. So again, you have your given and then things that you can imply from looking at your pictures. Now, all of this is going to help us realize and conclude that angle 4 is congruent to angle 4. Angle 1 is congruent to angle 4, and angle 3 is congruent to angle 5. And we can say that angle 4 congruent to angle 1, angle 5 congruent to angle 3, because if we have parallel lines, that implies alternate interior angles are congruent. And this is an idea that we learned in Unit 3 when we had parallel lines cut by a transversal. So here we are seeing this again in our proofs. So parallel lines cut by a transversal. So transversal AB creates angle 4 and angle 1, which are alternate interior angles. And on the other side, we have transversal BC, so angle 5 and angle 3 are alternate interior angles. And then the remaining of our proof, we're able to say that measure of angle 1 is equal to measure of angle 4, and measure of angle 3 is equal to the measure of angle 5, and that's because congruent angles always implies equal measure angles. And because we have equal measured angles, we can then substitute to our original statement with measure of angle 1, because measure of angle 1 is equal to measure of angle 4. We can then take measure of angle 1 and substitute it in for 4 in the original equation. So we now say measure of angle 1 plus measure of angle 2 plus measure of angle 3, because it got substituted since it equals 5. Measure of angle 5 got substituted with 3 to equal 180, and our reason is substitution property of equality. So if we look, this statement, measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180 degrees, is exactly what we were trying to prove. All right, next we want to look at some examples of triangles where we apply the triangle sum theorem. So looking at our first example, example 2a, We're given that angle A is 85, angle B is 55. We just want to find out the missing angle for C. So we can set up an equation that says measure of angle A plus measure of angle B plus measure of angle C equals 180 degrees. And then by substitution, we can say that 85 degrees plus 55 degrees plus measure of angle C equals 180 degrees. So we now have an equation that we can solve for measure of angle C. So we combine like terms, so the 85 plus the 55, and then subtract from the 180, resulting in measure of angle C equaling 40 degrees. Now let's look at our next example, example 2b. We have angle X, 117 degrees and 37 degrees. We're trying to find out what X equals. So we first set up an equation. We say that X plus 117 degrees plus 37 degrees equals 180. Combine like terms that are on the same side, so 117 plus 37 will combine, and then we'll subtract from 180 to move it to the other side, resulting in X equaling 26 degrees. All right, so let's take it up a notch and look at two more examples where we're using the triangle sum theorem. And now we're looking at expressions that represent our angle measures. So we'll start with this top left triangle where we see 2x plus 3 is one of the angles. X plus 12 is a different angle. And then we see our right angle symbol. So we know that this is our right triangle. And in our definitions, we understand that if we have a right triangle, then that means the other two angles must be acute. And it also means that they add up to be 90 degrees together because all three angles add up to 180 degrees. So if one of the angles is already a 90-degree angle, we can subtract that from 180, leaving us with the rest of the angles to sum to 90 degrees. So we set up our equation, so 2x plus 3 plus 90 plus x plus 12 equals 180. We combine like terms, so all the x's combine to be 3x, the 90 plus the 3 plus the 12 combine to be 105. We subtract the 105 from both sides, resulting in 3x equals 75. Then we divide both sides by 3, resulting in x equaling 25. And then we can plug in the x equaling 25 into each of our expressions to find out the angle measures. So when we plug in x is 25 for angle A, we get 2 times 25, which is 50. 50 plus 3 is 53. And then we can substitute 25 for x on angle C, so 25 plus 12 results in the measure of angle C being 37 degrees. Now let's take a look at our second example on this page. So example 2D. We have angle X, 2x, and x minus 20. So set up an equation in which all of the angles add up to be 180 degrees. Then combine like terms, resulting in 4x minus 20 equal 180. Then add 20 to both sides, resulting in 4x equals 200, then divide both sides by 4, resulting in x equaling 50. All right, so now we're going to substitute 50 in for each expression. And so 2 times 50, measure of angle A is going to be 100 degrees. And then 50 in for x, so 50 minus 20 degrees is going to be 30 degrees, so measure angle B is 30 degrees, and then substitute 50 in for x on angle C, and measure angle C is also going to be 50 degrees. So we have measure of angle A equals 100 degrees, measure angle B is 30 degrees, measure angle C is 50 degrees, and you can always double check to see if your work is correct by adding up all three angles and seeing if they add up to be 180 degrees, which is what it should be. All right, so now let's discuss our second theorem of 5.1. We have the exterior angle theorem. The exterior angle theorem says that the measure of the exterior angle is equal to the sum of the two non-adjacent interior angles. So here is our exterior angle, we'll call it angle 1. And we're saying, this theorem is saying that this angle 1 is equal to adding angle A plus angle B. And if you'll notice, it says two non-adjacent interior angles. And so if this is the exterior angle, then the two non-adjacent, so it's not this angle, the two non-adjacent would be angle A and angle B in this particular case. So we can say measure of angle A plus the measure of angle B equals the exterior angle, measure angle 1. So let's look at example 3 and see if we can set up an equation that helps us solve for x that ultimately helps us find the measure of angle JKM. So first we'll set up an equation. We'll say x plus 70 equals 2x minus 5. Again, the exterior angle equals the sum of the two non-adjacent angles. And now you're ready to just solve for x using your mad algebra skills. So we subtract x from both sides, resulting in an x minus 5 equals 70. And then we'll combine the minus 5 by adding 5 to both sides, resulting in x equaling 75. Again, x equaling 75 is not our final answer because that just tells us what x is. We now need to substitute x equaling 75 into every place we see x. So we know that angle J is going to be exactly 75 degrees because our expression is just x. But on the exterior angle, we have to substitute 75 in for x, multiply it by 2, then subtract 5. And when we do that, we get a measure of angle JKM is equal to 145 degrees. Let's take a look at one more example. Example 3a, find the measure of angle ACB. Hint, find x first. So that will always be your first step. And you're applying the exterior angle theorem to this example. And we know that exterior angle is equal to the sum of the two non-adjacent angles. So we can say 5x minus 10 equals 3x plus 40. Subtract 3x from both sides, resulting in 2x minus 10 equals 40. Then add 10 to both sides, resulting in 2x equals 50. Divide 2 on both sides, resulting in x equals 25. So now we substitute x equals 25 into our expression where we see 5x minus 10. And 25 times 5 will be 125, and then 125 minus 10 is 115. So the measure of angle ACD is equal to 115 degrees. And then since angle ACD, the exterior angle, is supplementary to its adjacent interior angle and form a linear pair, then we know that these two are supplementary angles, so we can subtract 115 degrees from 180 to figure out the measure of angle ACB, which results in 65 degrees. All right, next we have the corollary to the triangle sum theorem. And the corollary says that in a right triangle, the sum of the two non-right angles is 90 degrees. So I mentioned this a little bit earlier in the video. Here's our implied statement. Acute angles in a right triangle implies complementary. So if we have one right angle, we can subtract that from the total 180, leaving us with 90 degrees, which means angle E plus angle F must be 90 degrees. So let's use and apply this theorem to example 4. Please find the measure of angle J and the measure of angle L. Well, we know that the measure of angle J is x and the measure of angle L is 2x. So if we set up an equation, we can say that x plus 2x equals 90 degrees, and we combine like terms, resulting in 3x equals 90 degrees. Divide both sides by 3, resulting in x equaling 30. And since we're not solving for x, we're actually solving for the expression. So we can substitute x in for our expression. So angle J would be 30, and angle L would be 60. So we conclude that measure of angle J is 30 degrees and the measure of angle L is 60 degrees. Okay, so please try these on your own and we'll check them in class. All right, so that concludes our 2 objectives. So make sure you can classify triangles by sides and angles and find interior and exterior angle measures of triangles. The end. See you in class.